Hello everyone. Today I'd like to talk about age reversal and life extension. Note that none of this is to be taken as medical advice. This is a scientific discussion within pioneering areas of biology and medicine where the science is still very young. However, what we have discovered so far is extremely interesting and exciting. I want to show you a snapshot of what I call the human biological pathway space. And you can see there's quite a bit of possible interactions there, biochemical pathways. And so there's a lot of degrees of freedom. And before you get intimidated, I want to show you something else here. This is a snapshot of a portion of the city of New York. And it looks to have a very similar level of complexity, yet many people are very, very comfortable navigating within New York City or other large cities like this in North America. And so it's really not a question of whether you can do it or not. It's just what are you used to? And many times in biology, people seem to have their favorite pathway. And they often look like cartoon diagrams where there's there's a large restriction, very little degrees of freedom on how to make the particular molecule in question, whereas in real life there's typically a lot more freedom. So just to give you an example, if you were to get in a cabbie or an Uber and tell them that there's only 5 ways to get from Mapleton to Bensonhurst, they'd probably laugh you out of the car, because everyone knows in New York City with all the traffic jams and road work and everything, there's almost always many innumerable ways to get from one location to another location. And I believe it's very similar in the biological pathway space. And there's more there than we have even discovered. And going back to the biological pathway space diagram, I think especially with the advent of artificial intelligence and computer modeling of biological structures, geometries, and the interactions between the molecules, that we are going to be able to expand this biological pathway space by something in the order of 1,000-fold over the next 10 years. And we are going to experience and see dramatic discoveries building on what we've discovered so far. So let's get into it a little bit here. I want to emphasize the inherent simplicity of a lot of what we're going to be talking about. It's not complicated. So let's talk about, on the far right here, niacinamide. This is the niacinamide molecule. And you can see it's not that complicated. You got a cyclic hex ring with carbons and 1 nitrogen. And you got an oxygen, and you got a nitrogen and 2 hydrogens. I mean, that's not a complicated thing. If you look at a chair, an ordinary, let's say an office chair, that some of them have like 6 little wheels on it, and a far more complicated structure, but you know exactly what to do with that. And it establishes a pretty good bond too with the receptor with some parts of your anatomy. A good office chair, that is. So, and then let's look at nicotinamide mononucleotide. So, on the far right of that molecule, which is again this one's actually on the right-hand side. The other one was on the left-hand side. We see niacinamide on the portion of that on the most right, and it's connected to a sugar, ribose, in a ring form. In this case, it's a five-sided ring, pentyl, give it a word. And on the other side, you have a phosphate nucleotide. So the name is nicotinamide, which is another name for niacinamide, same thing. So nicotinamide, they don't talk about the ribose, but mononucleotide. So there's 1 nucleotide on the far left-hand side. So let's go to the next molecule here, which is NAD+. Now this metabolically is like the holy grail. And in terms of youth and health, it's part of the energy cycle. I'll have more to say about that, but it has a key role to play in many parts of the human biology and growth mechanisms and control functions. And this molecule can, if you can sustain it over a lifespan, it can make you healthy and maybe even extend your lifespan. But what happens over time is it typically drops and drops and drops, and things start shutting down. So very, very important. And then let's have a look at what this is in terms of what it's made of. The parts of the puzzle here. On the upper right hand, on the left hand side, but on the upper right hand of the molecule, we see nicotinamide again. So this is niacinamide, same thing, nicotinamide. You can recognize it from the previous chart. And in the middle, you got your ribose again, and so you can see that this top piece is the same as the previous one for nicotinamide mononucleotide. I'll go back even some of the. See on the right-hand side of the chart that NMN molecule, and then go to this one and go to the left, and you can see that the top there is basically that NMN molecule. And so you, again, talking about the pieces, and then you see on the left-hand side the dinucleotide. Then you got two ribose rings, and there's two dinucleotides, means there's two nucleotides on the left. And you got the ribose ring, top and bottom, and then you got this adenine group. So they call it nicotinamide adenine dinucleotide. You just read off the parts. It gets very, very simple very quickly here. And then NADH is another molecule. A lot of these are actually sold as supplements. You can buy them on Amazon and delivered to your door in like 1 or 2 days. This is very close to us. It's no longer a research laboratory, and you never see this stuff. And what they did with this molecule on the right-hand side, the NADH, was they took the nicotinamide adenine dinucleotide, the NAD+. They call it plus because it doesn't have the hydrogen. Well, they add the hydrogen, and it becomes NADH. So that's another thing we're going to be talking about. So just talking about NAD+, this is the target molecule, the holy grail of longevity research currently. So wouldn't it be great if we could just eat it and absorb it? If it was that simple, rather than having to inject it into ourselves. Personally, I don't like needles. I wouldn't want to have to inject myself every day. And then here we have a description of the benefits, I promise you, of NAD+, and I borrowed it from Life Extension. And I like this chart because it reminds me of Superman, Superman! And describing its superpowers. So this thing, let's go clockwise through it. It provides chromosome stability, and it provides DNA repair, immune cell signaling. It's part of those pathways. It allows you to produce energy enzymes, keep you vigorous. It helps the cells produce longer telomeres, and those, as they get shorter and shorter, they control the cell division process, arranging the chromosomes and in the right place, so forth. And when those get too small, they lose about 50 base pairs per division. And later on in life, in your 70s and 80s, especially the fast dividing tissues, the telomeres get shorter and shorter and too short, and they fray at the ends, and they can't separate the chromosomes properly, so you get a jumbled mix-up tangle, and that can even cause cancers to grow because it's changing the genome, so to speak. So you don't want to let your telomeres get short, and NAD can prevent that. So that's really exciting. And it also is involved in neurotransmitters, so if you want to keep your brain sharp in your 70s, 80s, 90s, and beyond, NAD+. And of course, but sirtuins, for longevity mechanisms, you have to keep your biological pathways, and the sirtuins stand for signaling information transfer functions, and so all the signaling, and so the body can coordinate itself rather than being like most bureaucracies. They get inefficient. The NAD fixes that. And energy production through the ATP, antiadenosine triphosphate system. And that's basically a quick summary. So we can move on here. Gotta adjust this. Now let's talk about some results. And I borrowed this from Professor David Sinclair from Harvard. And I hope he doesn't mind here, but this is a very exciting result, and I would like to talk about it. What they did was they gave in the water of one control group of mice, which were much older mice. They gave them nicotinamide mononucleotide, NMN, in the drinking water. And what they found was the mice became younger, and they became lean, and their fur on their backs were black. And they did this over a period of time, of course, not just in a day. And then they were testing it, and they took some young mice without the NMN, and they found that the old mouse not only ran a lot faster, and here you see it on the left-hand side of this treadmill, right at the front, but they ran faster far longer than the young mice could run without the NMN. In fact, it ran so fast that it broke the treadmill machine. And they had to find out what the problem was, and they found out what it was. The software was set for to be beyond what any mouse had ever done before. And they found that these old 70 to, I like to say 90-year-olds, so let me just say 90-year-old mice, even though they're like 70-year-old apparently. The 90-year-old mice were running beyond the life of the machine, so they adjusted it longer, and they found that these mice could run for over 3 kilometers. You can imagine a little mouse with little legs running 3 kilometers. So that's a very exciting development, and at times, I've been taking some of this stuff. I'll digress. I was working in my lab and developing some electromechanical optical equipment, and I needed to test it. So I was testing it, and I was underneath it. My ear was close to the floor, and there was a detonation beside this lab, and the shock waves bounced off the floor into my ear, and were damaging it. I had the sound of like a high-pressure steam pipe in my ear. Day and night, high-pressure steam, roaring. And I was concerned about that, so I read about what the implications of that would be. And ordinarily, I like to see it as the hair cells getting sheared off or some damaging mechanism like that. But the neurons in the ear respond to that by firing at a very fast rate for a very prolonged time. And ordinarily, they run out of energy and they die. And then you have a section of your ear without neurons, and you lose like a band gap of hearing. And I didn't want that to happen, so I looked to see what the preventatives were for this, and I found out that niacinamide could stimulate enough NAD plus to have the mitochondria multiply, and this would allow the cells to keep generating energy so that they wouldn't die, and you could survive the injury, and then the ear could heal, and you wouldn't lose any hearing. So I started taking these, and I was very happy. I don't think I lost any or much hearing in that ear, and it quieted down and everything. But one thing I wasn't expecting was I was out running about 2, maybe 3 weeks later, and I could not believe what was happening. I had to pinch myself, literally pinch myself, because this was like impossible. I must be dreaming. I was seeing the houses just whip by me, you know. And I even tried to leap into the air to see if I was dreaming, you know, like could I fly or something? No, but no, I couldn't fly. So I knew it was real, and I became very happy with. You know, you say to yourself, what's going on here? And I of course, connected it with my niacinamide I'd been taking. So it shouldn't surprise people that when people take this medication, some of them at least, I can, from my own personal experience, you become that mouse. Yeah, I don't want to go on and on. But that is my experience. So now let's look here into the oral ingestion of these chemicals. Because if it can't be absorbed into your body through the tablet, then what good is it other than, you know, treating your intestines for some condition? So let's look into it. We've got four chemicals here, four molecules: niacinamide, NADH, NAD+, and this new one, niacinamide riboside, which it's not a new molecule. This has been used, you know, it's by nature. And riboside is a sugar that's produced in human breast milk. But I want to look at the papers and see what they find. And here we're looking at one, see the red arrow, comparison of metabolic fates of nicotinamide, NAD+, move it so you can see better, NADH. And notice I have not, in this one paper, received information on nicotinamide riboside, but I'll get to that later. So 3 of them. Administered orally and administered intraperitoneally. Now, I don't know about you, but try saying that 5 times while juggling 5 peanut squashes and see how you do. It can trip you up. So let's just call it in the gut. It means you inject in the abdominal cavity. And I don't want to do that, so I'm focusing on the oral version of that. Let's just skip to the results, if I can. Well, no, I want to talk about one thing first. I always like to look at the acknowledgement sections to make sure that this is not an advertisement paper. There's a lot of those out there today, and they might not lie, but they might slant it in a certain way that leads you to more naturally to come to some conclusions that might not be as true as we'd like. So anyway, it says here that this investigation was supported from a grant from the Ministry of Health, Labor and Welfare. So this one is probably not an advertisement. And what they found was oral administration of NADH did not produce any increases in niacinamide or its metabolites, which, put it in lay terms, it means that it doesn't basically support what they found, support the internal cycle involving NAD+. So this one is because it's NAD with just the one hydrogen, and I personally find it amazing that just adding that one hydrogen could prevent it from entering the body and contributing in any way to that cycle. Let's move on to the bottom here with the red arrow. It says NADH is unstable in acidic conditions. Well, NAD plus is stable, so I'm starting to get excited. Maybe the NAD plus will be able to get through the system. It says NAD plus is efficiently digested in the small intestinal tract, producing niacinamide. So it produces niacinamide as it goes through, and that gets into the blood. So we're basically getting niacinamide and some of the other products, the other components like the breakdown of the riboside and adenosine, of course. That's from NAD+. So, and let's talk a bit about nicotinamide mononucleotide. Nicotinamide mononucleotide, NMN. And that's part of the breakdown product of NAD+. So if that was able to get through, it wouldn't, in this case, be broken into niacinamide as well. So we know that that one breaks down, and I've seen it in other papers as well, so we know the breakdown products for that. Which means it's time to summarize, what do we know so far from looking at this? Well, let me just say that. NADH breaks down in the human gut without apparent contribution to this cycle we're interested in. NAD plus doesn't get through. It's absorbed as niacinamide, ribose, phosphate, and adenosine, and each of those individual components get through. NMN is also absorbed as Na and niacinamide, ribose, and phosphate. No adenosine is in it, so that doesn't go in. And niacinamide is absorbed as niacinamide. So you see niacinamide, 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 and the possibility of supplementing some of the more difficult chemicals to produce, which might be ribose sugar. So we'll talk about that later. But that's what we've found out so far. So now let's look at nicotinamide riboside and see what we can find in this different paper, which is entitled Understanding the Physicochemical Properties and Degradation Kinetics of Nicotinamide Riboside, a Promising Vitamin B3 Nutritional Supplement. Okay, so remember, we're interested in here in seeing whether an oral tablet can get through the system into the blood. So down below here it says the results have shown that N, which is basically nicotinamide riboside chloride, is a labile, which means it can break down. It's a delicate molecule that changes shape and form, that degrades to form a possibly antagonistic product when exposed to either gastric fluid or elevated temperature. So that's not looking promising. Let's continue and see what the final conclusions are. The conclusion is that 1 mole, which is a quantity, Avogadro's number, of NR breaks down to 1 mole of niacinamide and enable, okay, so blah, blah, blah. So that tells us what the breakdown products in the human digestive system are for nicotinamide riboside, and whether you need to inject it or not to get the benefits. So let's again tie in for another summary. We've already talked about what we had before, but let's focus now on for the other 4 chemicals. But what about this nicotinamide riboside? It says here, summary, that nicotinamide riboside is absorbed as niacinamide and ribose in the gut. Well, so we have found from the papers that there's an apparent equivalence between niacinamide plus ribose and nicotinamide riboside in the intestine if you make sure that the doses are equivalent. I'm just looking at this. Several studies indicate that nicotinamide riboside taken orally breaks down into niacinamide and ribose sugar. And so from this, we want to be sure we always differentiate between the results promised from an oral application to the results promised from when they inject it, as for example in the gut. So I have another question here. Should we then take niacinamide and riboside separately? We can control the doses between the two and that sort of thing. And it might be more cost effective. And so let's just check that. So I found this one online in Amazon, and I'm not affiliated with any of these companies. I just wanted to get this information to get a price here. $48 for, and they say they have to take 2 tablets per 1 dose, 300 milligrams. So that gives me the price point. And then let's look at niacinamide. You can get that for 200 counts, 200 tablets, 500 milligrams for $7.23. Pretty inexpensive. And when I do my arithmetic, assuming that nicotinamide riboside breaks down into 50% nicotinamide and 50% D-riboside, which is going to be close enough, I think, for this calculation. I do the arithmetic and come up with that. If and these are rough numbers, but to get um, a nicotinamide riboside dose, I got to take one word out of here. And just stay with me for a second. I don't want to put a brand in there, so I hope you didn't even notice that. Anyway, it comes out to $1.60 per serving. And on the other side here, a mixture of niacinamide and D-riboside, it works out to 2.8 cents per serving. So in this particular calculation, buying nicotinamide riboside costs 57 times more for what might be the same pharmaceutical effect. I would love to have a study to verify that, but so let's take this as a working hypothesis at this moment. So one of the points I have here is just a reminder. While you're reading these studies, always try to keep track of the method of delivery and whether in this case it's oral or an injection. Because you may be promised things that you might not be capable in either of those two, or one of either. So how much, how often? So again, I can't give medical advice, but personally, I take 500 milligrams of niacinamide every second day. And I do that, I want to give my body a rest. I always try to be on the conservative side, safe side. And that works out to 250 milligrams per day. But like I said, I hold off for one day. And I want to give my body a rest and allow the other necessary cycles, the sirtuins, etc., to be carried out without any interference from the niacinamide. In other words, if you have your system tied up in one cycle and it might be hogging the cyclic space and maybe interfering inadvertently with something else going on that we do know or maybe don't even know. Also, every second day to allow the methyl groups and other agents to be fully restored. So I want the system to be topped up. I don't want to drain any portion of a vital cycle. I want to bring up one thing. In the animal studies, they're able to extend the life of animals, but the ones that they extend the life on are what they call knockout animals. And these are ones where they took certain things out of the genome so that to shorten their lifespan. And then after that, they're able to expand the lifetime 30%. But to my knowledge, today, they're not able to take a wild type animal and extend the lifetime 30%. So that makes me really, really wonder. It's like, but they can make the wild type animal a lot healthier, a lot longer. So, you would expect a healthier animal to live a lot longer. And I want to know what's killing those healthy animals. What are they dying of? And it seems like they might be running out of something. So it's good to be conservative, be careful with this thing, and that's the reason that my intuition tells me give the body a rest. It's like drinking coffee. You don't want to drink coffee every day in large amounts. You got to give your body rest, or otherwise you burn yourself out. Same with this. I propose. So what else do I take? Well, I take vitamin B12, 1,000 micrograms. I take that every day. It's just a supplement. And I take methylfolate. Methyl, because folic acid, I don't think it's bioavailable. So I take methylfolate, as far as I know and I've researched this, that's able to get into the body. And that supports the methylization that a lot of these cycles use up. And the niacinamide cycle actually consumes methyl groups, and you want to replenish those because your body needs them. So it's very important to take this methylfolate, and I take it every day. It also, the niacinamide cycle actually produces homocysteine. And this might be a clue because homocysteine, it forms crystals in any high quantities in the bloodstream and scratches the artery linings, and it causes deposition of cholesterol and other damage. to your arteries, maybe stiffening them. So you don't want too high a homocysteine level, and you can get that anyway because it's hard to get enough folate in the diet. You look at what you need and what you get in your diet, usually you don't get what you need. So for that reason, and because we're using niacinamide, which increases the need, you really need to get your methylfolate. So with that, thank you very much. I've enjoyed giving this presentation. I hope you were able to enjoy it and found it useful. And remember, this is a lot of these answers are not the final story, but we're making progress, and some of these things are hypotheses. It's early. We're early on in this yet, but it's very, very exciting. And I'll have more to say about this later. So thank you very much.